Hello guys, I'm Goran and this is Tiago, and we are going to be working on our Camaro project. If you remember well, in the first video we explained you what our project will do, and in this video we'll go a little bit more detail. As you can see, we got our special tool, so this is a Raspberry Pi, and we will be using this tool to connect it to the OBD reader and retrieve the data to our system. For more details, Tiago will...
We're going to be using the Raspberry Pi to get the data out of the car. And then after that, we're going to show them how to automate all of that so it's easier with some custom Python code.
I'm sorry, I'm afraid of Python, so I can't help you here. Like, yes, man.
It's
Python,
not a...
Python, man, come on.
Don't be a jerk. Are you serious? I guess I'm doing this alone. We got our Raspberry Pi and today we're going to use it to fetch data from the car. This is the Raspberry Pi. As you can see, it's quite small, portable, lightweight, and it's basically like a mini computer with inputs like USB and network cable and outputs like the mini HDMI port. Right now, it's basically like a block of hardware with no hard disk, which is where typically the operating system is installed. On the Raspberry Pi, the hard disk is replaced by an SD card. Follow the link below to download and install the Raspberry Pi's operating system on the SD card. Also, important to mention that like any other computer, we need a screen, we need mouse, we need keyboard to be able to interface with the computer. Now that the SD card has been inserted in the Raspberry Pi, we plug in the power cord and it starts automatically. As you can see, we have a desktop like if it was any other computer. So we're going to start by going to Preferences and Raspberry Pi configuration here. We do a quick step before anything else. That step is changing our default user's password. As you can see, our default user is named Pi, and we're about to give it a password. Confirm password, click OK, change successfully. Perfect. So, we want to make the Raspberry Pi as portable as we can. We cannot go everywhere with a keyboard, mouse, and screen. To do so, we're going to enable a remote desktop for it, so we can use our laptop and control it remotely. To enable that, we're going to go back to our Raspberry Pi configuration window. In it, we have an interface tab. In that tab, the second option is VNC, which stands for Virtual Network Computing. This is basically a service that allows us to remote control the desktop. We're gonna enable it and click OK. You can see in the upper right corner that we have a VNC server now, which was not there before. This VNC server will allow us to use the laptop to connect to the Raspberry Pi remotely and control it. To do so, we need two things. We need a VNC client that we're gonna install on our laptop, and we need the Raspberry Pi and laptop to be on the same network. For the VNC client, we're going to install a program called VNC Viewer, which is free for non-commercial use. For the network, we're going to connect both the Pi and the laptop to the Wi-Fi. The problem is we want the Raspberry Pi to be as portable as we can. So we're going to connect to the phone's hotspot. Like this, we can carry the phone with the Raspberry Pi and the laptop, and we can do this anywhere. After switching on the phone's hotspot, we're going to go back to the Raspberry Pi on the upper right corner and click on this icon, which is the network settings. On it, we can find our phone's hotspot Wi-Fi, which we're going to connect to, put in that password, and the moment it's connected, it's time to do the same for the laptop. Now that we're connected to the phone's hotspot with the laptop, we're going to open VNC Viewer. As you can see, the VNC client asks for the VNC server's address, which in this case is the Raspberry Pi's address. To find that address, we're going to go back to the Raspberry Pi and open a terminal window. On the terminal, we're going to use the command ifconfig. This command allows us to see information about the network, including on our wireless connection, the IP address. This IP address is the Raspberry Pi's unique identifier on the network, and that's exactly what we're going to use on the laptop to connect to the VNC server. We put in the IP address, click enter, and the moment it is connected, it will ask for a username and password. We're going to use our Raspberry Pi's default user, Pi, and the password we just put in. I'm going to check remember password so I don't have to input it every time I want to remote control the Raspberry Pi. Click OK. As you can see now I have total access to the Raspberry Pi's desktop. I can move in the mouse, I can close windows, and with this the initial setup is done and the Raspberry Pi is ready to be used wherever we want, whenever we want, with nothing but the power cord. Finally we got rid of all that stuff and we are left with nothing but the Raspberry Pi. So, how to actually fetch that data from the car? Let me show you. We have Raspberry Pi powered by a USB cable plugged to the car. Have the mobile hotspot on, so the Raspberry Pi and the laptop can be on the same network. And our OBD reader also plugged in the car. Okay, first of all, let's establish the Bluetooth connection. So open a terminal window here. Use the command Bluetooth CTL. Okay, so this allows us to control the Bluetooth connections of the Raspberry Pi. So let's start it up first. Power on, parable on, agent on, and default agent. Okay, let's start up the scan on. Now we're scanning for all devices available, and wait, there it is, our OBD2. Let's just copy the MAC address. Okay, now we can pair and paste the MAC address so we can pair to the OBD. Oh, asking for a pin, the very standard 1, 2, 3, 4. Enter. Pairing successful. That's awesome. Now we also trust it. Trust, paste MAC address. Yes. Trust succeeded. Perfect. Awesome. So Bluetooth connection is enabled and the Raspberry Pi and the OBD reader are connected. The next step is to send the data, right? So to be able to do that, we need to bind the Bluetooth connection to a serial port, because all the data flowing between the devices will happen with the serial communication. So to do that, we'll open a new terminal and we'll use this command rfcomm bind. What are we binding together? We're binding our Bluetooth and our serial. So first the serial dev rfcomm 0, that's our serial port, and the MAC address of our OBD, so the Bluetooth connection. Press enter and there it is. They're bound together, meaning that all the communication happened between them will pass through serial communication, and if we want to use that serial communication, we'll just mention the serial port that we just bound. Okay, so for the purpose of the demonstration, I'm going to use this serial communication program, and any standard one will do. That's okay. So let's go for serial, and our serial line will be our serial port, so rfcomm 0. There it is. Perfect. So all the programs that we're using, their names will be in the description, so don't worry about that. The speed 9600 is fine, so that's okay. Let's just open it. Okay, perfect. Okay, so everything we type in this window will actually be sent to the OBD connector from the Raspberry Pi. Everything. So to the car. Now let's try a very simple command, atz there. This will give us the OBD version back, OBD2 v1.5. Awesome, that's great. So let's query some real data real quick. Let's run this command 010c. Type in, there you go. This will give us the engine speed, the RPMs of the car. So let's press enter, and oh, there it is. So you got the 010c, which is the command we just sent. and 0948 hexadecimal. So this will of course have to be translated to decimal, human readable value. Awesome. So seems like it's working. We're getting data from the car.
In order to automate all of that, we've decided to build our own custom Python code. In that code, we're going to put the whole list of codes that we want to query the car for, get all the values, and then display them on screen. To do the code, we use this free program called PyCharm Community Edition. It's very easy to use. It has a lot of very cool features. I'll put the download link in the description so you can also get it if you wish. As we've seen before, we start by opening a Bluetooth connection with the OBD reader, binding that connection to a serial port so that we can actually send data through. In our Python code, we create the serial object to be able to use that serial connection. And then we finally open that serial object so we can start sending data. We send the data one code at a time, and then we get the response back. We save that response based on whether or not it has data. If it has no usable data, we'll record it as S so we can keep track. If it has actual data, then we transform it into an integer. Why an integer? Because the response received is actually a numerical value of the measurement that we've been querying. We keep querying code after code after code until we finally get an entire package of the values. Once we have an entire package of values, we print them on screen. So we print a text description of the PID code we've queried, plus a calculated value based on the response that we got, so that we can get something that is human readable. And that is what we're gonna see in just a minute.
Okay, so we're here back in the Camaro. I have my VNC viewer connected to the Raspberry Pi, and we're ready to test this code. So let's go, open it up. So the Raspberry Pi already comes out of the box with a program to run the Python code, so you don't need to install a third-party one, which is pretty cool. So everything is set, we just need to click run, and let's see our code running. Connecting, and oh, it's querying, and we're getting data back. Okay, it seems quite nice. Okay, so let's make sure that this is actually real data and the values are changing accordingly. I have something, oh, of course, engine speed. Let's check the engine speed. We're around 600 RPM right now. Let's see it go up. Oh, there, and going back down. Ah, that's perfect. Also the throttle position, going up and going back down. Ah, that's perfect. Perfect. We're getting our data back. All of them human readable values, so converted. Perfect. Even the refresh rate is quite good. Awesome. Looks like the code is working as expected. Let's go back up. We're back in the studio, and that's pretty much it for this week. We learned how to configure a Raspberry Pi, how to get data from the car with the Raspberry Pi through the OBD connector, and how to automate all of that with some Python coding. We just
Hey man,
tested
what's
all
up?
that, so that's...
Hey! Sorry, I was super busy, like all day. Did you finish with the Python code?
For now, yes.
Ah, great. Good job, huh?
Ah, okay. I guess Goran is done, so here he is, back. Anyway, so now that that is done, on the next video we'll be using some MuleSoft APIs that we'll be developing to send all that data to the cloud so we can do whatever we want with it.
That's great. So, thank you guys for watching, and we'll be seeing you in the next video. Don't forget to like and subscribe, and yeah, have a nice day.
I guess so. Bye.
Have a nice one. Have a good